Hello students, welcome to the channel of Parallax Tutorial. My name is Pallabi and this is our sixth video on the series of topic-wise past paper questions of IBAAHL Mathematics Paper 1. We are covering the topic of functions. We'll be solving the part D along with all the subparts in this video. For the solutions to the previous parts, you may click on the link given in the description. Since this is a no calculator paper, we'll be learning how to find the inverse of a function and also how to graph inverse functions and compare them with the original functions graph in this video. We are going to cover part D and all the subparts of D. So the first subpart asks us to find an expression for inverse function, f inverse of x. Very quickly, I'm going to revise the concept of inverse functions. So as you see, inverse of a function is also a function, right? Now let's very quickly understand this. So we have a function f of x. Let's say this is the domain, which is all the input values which you can put into the function, all the x values basically, and you get the corresponding y values, right? The y values are also called the fx values, right? Fx and y are interchangeable because it's f of x. Y is a function of x. Let's say we have another function which we will call, for the time being, inverse of x, okay? And in that inverse of x, we input these y values, which means we are inputting the f of x into that inverse of x. That means the domain of this function would be what? What would be the domain of this inverse function? It will be the y values of the previous one, right? That's the reason why we interchange x and y. Now, if we input the y values in inverse function, and when we do that, if we get back our original x values, which was this, then we say that f inverse of x is a function, is inverse to the function f of x. Now, this was the physical meaning of inverse functions, right? But how do we calculate it mathematically? So here's what we are going to do. So we are given a function f of x, which is equal to 2x minus 1 by x plus 2. We call it, let y be equal to 2x minus 1 by x plus 2. Clearly, y is your output, which you will get from f of x. Now, what we do is we interchange the x and y's, which means x is equal to 2y minus 1 by y plus 2. The reason we are doing is, I have already explained this, the y values are your x input values for inverse function, right? Now, again, make y the subject. So what do we get? xy plus 2x is equal to 2y minus 1. xy minus 2y will be minus 1 minus 2x. And y, x minus 2 would be minus 1 minus 2x. So y would be, I'm just switching the sign over here. So this will be 1 plus 2x or 2x plus 1 divided by 2 minus x. I've just switched the sign, so this sign also becomes positive. Why have I done that? Just so that my function becomes easier to solve. So f inverse of x comes out to be 2x plus 1 by 2 minus x. This is my expression for inverse of x. Now comes the second part, which is sketch the graph of y is equal to f of x, showing the points of intersection with both axes. And the third part is also kind of combined with it, where we have to sketch the graph of inverse of f of x on the same diagram, right? So let's start with sketching f of x first. So we'll draw our graph over here. See, the important points over here to note whenever you're sketching a function is whether there are any asymptotes for which the function is not defined. Those are called asymptote values. It can be either horizontal, it can be either vertical. Let's see for this function, what do we have? So if you look at the function, remember there is a domain given to it, which means all the input values which you can take will go from minus 1 all the way till plus 8, right? Those are the values which you will get. Okay. f of x is 2x minus 1 by x plus 2. Clearly, if we put the x value as negative 2, then the function will not exist, right? Although it is not part of the domain, but just in case the domain was not given to you, you should know that at x is equal to minus 2, that is this line which I have drawn, the function is not defined. So it is a vertical asymptote for the function. Let's see if there is any horizontal asymptote as well for this function. How to find horizontal asymptote? Now I'll show you an easy way to figure out horizontal asymptote for any function. So y, horizontal means the y value, right? It has to be a straight line, horizontal line, and only one y value, and any x value can be there. So y is equal to 2x minus 1 by x plus 2. This is what we have. And which means if we just take the x plus 2 in the other side, what do we get? X plus 2 into y will be 2x minus 1. Xy plus 2y would be 2x minus 1. We are trying to make x the subject here. So xy minus 2x would be minus 1 minus 2y. X into y minus 2 would be minus 1 minus 2y. X would be 1 plus 2y by 2 minus y, right? Again, clearly, over here, what do we see? If we take the y value as 2, which means over here, right? This is y value. This is having the y value as 2. So if we take y as 2, the function will have a horizontal asymptote over here. So for y is equal to 2, there is a horizontal asymptote in the given domain. And for x is equal to minus 2, we have a vertical asymptote, although for this particular function, it's not there because it's not part of the domain. Okay. Having understood this, now let's sketch the graph. So the next thing which we should know about sketching graphs of functions is where do they cut the x and the y axis, right? So I'm going to erase this part so that we can work out over here. And let's see where all the function cuts. So this is 0, 0. We have the function as 2x minus 1 by, I keep writing this again and again because for every part you need to know what function you're working on. Okay, so let's put x as 0 and check out the intercept, that is the y-intercept. When we put x as 0, wherever the function cuts the y-axis, that would be our y-intercept. So let's put x as 0. What do we get? 2 into 0 minus 1 by 0 plus 2. So what did we get here? Minus 1 by 2 is our f of x value or y value, which means minus 1 by 2 would be over here. That's one thing. Okay. Then let's find out which one is the x-intercept, which means y is 0. So 2x minus 1 by x plus 2. So 2x minus 1 is 0. So x is equal to 1 by 2. X is equal to 1 by 2 would be our y-intercept, x-intercept. And the function would look like this, right? It will, the y is equal to 2 is our horizontal asymptote, and it is only up till minus 1. So you can see what the value of the function would be at x is equal to minus 1. Let's do that as well, which means at x is equal to minus 1, which means f of minus 1 would be 2 into minus 1 by minus 1 plus 2, minus 2 minus 1, which is minus 3 by 1. So minus 3. It will be roughly over here. So this is our function. And this is the sketch of the function roughly for this particular situation. That is part 2. Now coming to the third part. On the same diagram, sketch the graph of y is equal to f inverse of x. Now this is very important. How do we know that how to sketch the graph of an inverse function? Now there are two ways. You can look at the graph and from the graph you sketch the inverse function, or you have the inverse function with you and you do the same plotting which we did for f of x, you do the same for inverse function and plot the graph. Now, for the second case, if you know the inverse function, then you can easily plot the graph. But what if the graph is not, what if the function is not given to you? You may have to plot it from the graph, right? So what do? We know that we draw a line which is y is equal to x line. Let's draw that. So this is our y is equal to x line, which means across this line, y values are exactly equal to the x values. Remember, in my previous video, I have mentioned this. An inverse function is just a reflection of the original function on this y is equal to x line. I repeat, inverse function will be the reflection of our original function on this line, which means that if we have to draw the inverse of this function, our function would be just equidistant from this line, which means it will be something of this sort. Let's say our blue function is inverse function and it will be something like this, right? This is how it should be. And obviously, as you can see, it's not very clear, but roughly this is the shape. But the question is you have to sketch the graph, which means you should show the point of intersection of the inverse function with the x and y axis, right? Okay. So the point of intersection of our original function, first let's write down those points. So this point was, the x-intercept was 1/2, comma 0. Y-intercept was -1/2, 0, comma -1/2. So over here, our x-intercept over here in the inverse function would be roughly the opposite of this, -1/2, comma 0, and the y-intercept would be 1/2, 0, comma 1/2. Correct? So we have marked all the x and the y-intercepts, and I'm just going to show you how this function looks like in the actual graph, right? So let's have a look. I'm just going to share my Desmos screen, although this is not allowed in your exam, but just to give you the feel of how the function looks like. So look at this. We have y, this is our original function. 2x minus 1, this was the green curve which you see is our original function. The black curve is the inverse function. And I also put a line y is equal to x over here. So as you can see, let's look at the points as well. So we see that the x here, this is the intercept, -1/2, comma 0. This is 0, comma 1/2. This is 0, comma -1/2, and this is 1/2, comma 0. So this is how the intercepts are, and clearly as you see, both the functions, the blue, the black and the green, they are reflected along the line y is equal to x, which is the red line over here. So this is how an inverse function looks like on the graph. And that's all for this video. Thank you so much.